It's 4 o'clock here in the Netherlands. Welcome everybody to the new Qualogy Oracle Tech. Oh, no, not Oracle. Qualogy Tech series. Today we have Gerald Venzl, distinguished product manager for Oracle. Gerald done a lot of things from a developer, DBA, performance tuner, etc. And now he's the distinguished product manager. Talk about the database for the developers. If you take over the screen, Gerald, you can go here. Go ahead.
Perfect. Thank you very much. So you should all see now my screen and my slides. So thank you very much all for there we go, being here and for this webinar. I'll give you in the next about 50 minutes a quick overview of what we have done with Oracle Database for all the developers, all the functionalities, all the integrations to make life easier for developers to use the database, but also how to use Oracle Database with modern development technologies and methodologies, whether these are microservices, distributed architectures, and. Please keep it interactive. If you have any questions, please put them in chat. Patrick will monitor them. And, you know, the more questions I get and can answer, the more interactive it also becomes to me rather than talking to myself and the webcam. So please keep the questions coming. Also, Pete, you can keep them coming as well. You know, like really the slide deck is only kind of like a very high level overview of what the developer ecosystem looks like for Oracle Database. In about 25 minutes, you could probably fill a whole week if you drill down into every area and probably much more. And then just a quick recap on the latest innovations that we have done with Oracle Database for application development, mostly because, and I always like to say this, we still have a lot of people that just are coming from 11G up. And, you know, like 18C, 12, 201, these are all releases that are, depending on your support contract, are either already out of support or going out of support very soon. 11G definitely is out of support. So there's a lot that happened between 2007 when we released 11G R2 and 2020. So we'll give you a brief glimpse of all the new things that await you when you come to an Oracle database and all the goodies that we have been busy ourselves building. Oracle database at the developer ecosystem. So when we look at the competition, what they say, it's like Oracle database is old, there's no innovation, it's expensive, it's not flexible, it's complex, etc. Basically, don't use Oracle database because, you know, it's a 40-year-old product. And yeah, it's true. Oracle database was the first commercial relational database out there, and it's actually still alive. And #1 database after 40 years, which in itself in the IT industry already speaks a lot, because many technologies come and go in 2-3 years time span. But also, you know, when you think about it, it's like, is it really a bad thing that a technology is around for longer or not? It's like Linux came from the 90s, everybody uses Linux. Java is from the 90s, everybody uses Java. So you could actually turn this around and say, if you're kind of like a newish technology, you know, maybe you're modern, hyped, etc. Or maybe you are in your infancy steps and you actually have to mature to that level for the requirements that your developers and also your customers themselves, or the users of the product, actually have. When you actually look at Oracle database and these newcomers, it's like, especially the newcomers that kind of come in and say, you know, everything that's kind of older than 5 years is like legacy or whatever. They have a lot of these limitations, right? It's like just naturally, you know, as the product matures, you add more and more functionality to it, or the other way around, you know, you add more and more functionality to it because the product matures. What does that mean? Well, customers come in, ask you, you know, hey, we would like this, we need this, etc. It's not like that. We have been just sitting around for the last 20 years doing nothing. And when you turn to the newer systems, they usually tend to have all the same issues. So they come out, they focus on something, or maybe not even issues, but the story remains the same. It's like they come out, they address one specific area very well, focus on that, start with that, right? And then as they progress and get bigger, they tend to then also come to things like, hey, you know, maybe transactions are a good thing. Hey, maybe, you know, this and that is a good thing. And, you know, just to quickly call out, the NoSQL space is very infamous for this, right? They came out with like, we don't need SQL, and literally every NoSQL database has some kind of SQL engine on top of it now. So, and now they say, well, that no actually stood for not only SQL. So all of these things come in, and, you know, when you look at Oracle, there's a lot of these things that they don't even have yet. And it took us years, frankly, to get there. And everybody's working hard to get to something similar. You know, asset transactions is one of them, but the no blocking of readers and writers with the multi-version read concurrency control. So something that actually Oracle was the forerunner by a long shot compared to everybody else, made Oracle actually one of the main reasons why Oracle scales as well as it does. But also rich SQL support, smart query optimizers, right? It's like took us a long time from rule-based optimizer to the cost-based optimizer and beyond to actually just allow developers to issue a SQL statement, and they don't have to think about anymore how they would join the tables, or, you know, whether there should be an index used or not, right? The optimizer has gone a long way. And there's many other advances in there. And, you know, why is this important? Because it's really for you know, when we get these comments from like, oh, it's legacy, it's old, etc. It's like usually the average user or developer, they don't tend to think of advanced functionality until you need it, right? It's quite normal, right? It's like everybody is the same. It's like, okay, you have a specific need, you solve that need, etc. But when you scale it to thousands of users, you actually get other needs that you will not have discovered before, right? Or when you scale it to terabytes or petabytes of data, you will have other needs that you didn't need to worry about when you built this on your laptop. And that's why we kind of need to, whenever we have this conversation, remind ourselves of like, yes, this looks good, but right, what about all the other functionalities that you eventually will need as your systems, as your applications grow, and so forth. And, you know, like these things that we just put here on slide is you know, a very brief glimpse. And that's only probably what 90% of developers know, right? It's like there's much more that Oracle database provides, and chances are the average person doesn't even know. Chances are I don't probably even know. There's so much functionality in the Oracle database that has been added over those 40 years. So it's always a good thing also to kind of keep looking into the developers guides that we have in the documentation, into new features guides when the new release is coming out, and just familiarize yourself with what's actually already in there before perhaps going off and building in the application by yourself. A couple of more that we have here that are really important in when we do get to larger operations. As I said before, when you do get to multiple terabytes or petabytes of data, like the one that's very important right now that gets a lot of attention right now is multi-model support. So the fact that we say, you know, we no longer want to store just relational data or just data in rows and columns, right? We want to be able to store JSON, we want to be able to store graph, and we actually would like to store it in the same engine so that we don't have to stand up different databases next to each other and then have to figure out how to integrate the data. Parallel queries, flashback, deep instrumentation, these are all the things that you actually get to when your system grows. So these are things that developers probably don't even think about until they actually hit this threshold where the system has become so big that they now worry about these things. And, you know, some of this stuff is what other technologies now are introducing, right? Years and years after they're like, yeah, we are new, etc. Now they get to similar pain points, right? It's like a popular example here would be MongoDB starting to add transactions in there in some very fundamental and primitive form, right? While they a couple of years ago said transactions, nobody needs this. It's all good without transactions. When you look at the database itself, you know, Oracle is by far the most resilient and secure database. And there's if you want to slice and dice it, there's a couple of different areas that we're focusing on and that we advance in parallel with different teams that we have here in Oracle. You know, on the bottom is the infrastructure security, like all the things that, you know, people care about to secure your data, right? to not lose your data, have your data stolen, etc. But then on top of that, or next to that, would be infrastructure resilience, right? It's like database is only so good if it's actually up and running and you can access your data, right? Nobody wants a database that keeps on failing or falling over. And on its core are the things that are really the things we use to analyze the data, manipulate the data, manage the data, etc. Basically, those things that the developers will use or the users will leverage to make sure that they manage the data to analyze the data to their needs. When we look on top of languages, we have support for all the modern programming languages, or all the, I should say, popular programming languages. When, you know, it's like what's modern, what's not modern, right? It's like Java, JavaScript, and Python, all very popular. They actually all from the 90s, right? So like, are they modern or not? But when you look at it, for the chances are that whatever programming languages you use today in your environment, there is a driver for Oracle database. You can use, you can access the Oracle database with it. You can leverage and use the Oracle database with it. This again here as well is only just a very short list of what we have. There's actually multiple adapters and connectors and drivers to other programming languages, you know, as well as ODBC and other of these adapters that are still around there as well to use and connect to your database. I'm sorry for my mouse moving a bit around. It just pushed my face out of half of the slide so I could read the rest of it. But then, you know, on top of that, we offer, you know, SQL and PLSQL. SQL, our SQL engine, we think is the most sophisticated, most advanced SQL engine when it comes to analyzing and managing your data, especially on a large scale. And PLSQL is the most advanced in database programming language, right? Or whether you want to call it user-defined functions, stored procedures, whatever, that language inside of the database. Some other databases don't even have the capability to allow you to put a piece of logic into the database. Some have just very fundamental support. We drive the whole Apex environment of PLSQL. Eventually, many more applications are just written in, and so sometimes pure PLSQL and SQL. Top of that, we give you free tools, you know, SQL Developer, loved and widely used by the developer community, the IDE tool to leverage an Oracle database or to develop against an Oracle database. It also comes with a data model with it. We have a Visual Studio Code plugin, and we have a new command line SQL CL that has, so we have SQL Plus, we have SQL CL. SQL CL is a newer version, a Java-based version of the command line prompt, both to user fine. SQL CL has a couple of really nice advantages built in, including a plugin system. And so one of these things that we have is an advanced liquid-based support, or advanced plugin for advanced liquid-based integration. And I have a slide on this just a little bit later. And then also APIs are very important to go down to. So, you know, it's like not every developer wants to just hand code the SQL statements in the application, whether that is because if the SQL ever changes, you have to recompile your application, ship it again, etc. But also just for the needs of saying that, you know, you want to abstract eventually to a higher abstraction level, where perhaps you use an API call, and there again, whether you call a PLSQL procedure or you actually use, for example, for our JSON support with collection APIs that are more natural to JSON workload, or just abstract everything via REST APIs. All of this is there in and around the Oracle database. And most important, everything of this slide that I'm showing you, see this big sticker on the top right, is free. There's no additional charge with it, no option or anything like that. You can leverage all of these today with your Oracle database at no extra cost. When you look into the data types themselves, here as well, very important. As said before, multi-model has become very important in the last couple of years, right? Not all data is relational, or perhaps it is, perhaps it isn't. We at Oracle think that our philosophy is more around, just because you want to manage a different data type should not mean you have to use a different database technology. Mostly what you see is as you want to manage different data types, you fragment your data management landscape. So you basically bring more and more different database technologies in. And it's not even about whether these technologies are as good or not as Oracle or better, etc. It's like mostly what you see is that, and especially with the trends of microservices, of providing a new database with each microservice, sometimes you can very quickly get to 20, 30 different database technologies if you really let everybody choose freely. There's like over 300 different database technologies on DB engines, if you want to look it up. So you can imagine it's like, as you proliferate that landscape, managing and securing that becomes really, really important, or becomes really, really difficult actually, right? Because now your admin kind of has to be an expert in all of these technologies. So we believe that actually, hey, if you do have another data type, you should be able to store it in an Oracle database, and have the benefits of all the good functionalities that we have around this infrastructure resilience and infrastructure security side of things, right? And so that is actually something we're doing since a long, long time. In the mid-90s, we started doing that by adding object support into the database. And by now, we have many, many more different data types that you can store and manage natively in the Oracle database. And then when you look at it, storing is one thing. Storing is frankly quite easy because, eventually any database storing some data is like, yeah, you put it on disk. It's like I can store any data in a blob if I wanted to, right? But that doesn't mean you can actually process it in the ways you want, or that you can actually access it in the way that you want. And this brings us to the right-hand side, right? As you store the data, you have different requirements that you want to go through, right? Whether that's partitioning it, share it, represent it, columnar, compress it, encrypt it, streaming, facilitate IoT workloads where you basically have asynchronous commit, or perhaps you don't want to store it in the database at all. Perhaps you want to just access different external data sitting somewhere else, but still leverage the power of a SQL engine over it, etc., etc. And we facilitate this all in an Oracle database. And here again, the importance here is that essentially we provide the flexibility, and to some extent much more flexibility than the newcomers that say we are inflexible, to allow you to store different types of data. And we're doing so that you don't have to stand up another database if you don't need to or want to. Often we see use cases where, yes, I have a piece of JSON, actually maybe want to store it alongside my relational data. Maybe I want to store it alongside my customer records, etc., and query it together. If you store it in two different databases, this becomes much more difficult. If you don't, this becomes much easier. Deployments is another really important aspect to, where can I actually run this database? How can I run this database? Because for a developer, as well as for IT, of course, but for a developer, you want to kind of, make this fit in your environment that you're comfortable developing in or that you're using already, right? And so can I install it on my laptop, right? Can I install it on premise, etc.? Yes, you can. Here, a quick shout out also to our free Express edition, database edition that we have, that is fully free of charge. Anybody can download and just get going. Do you want to run it containerized? Here we actually provide inside the database a similar containerization technology that what you would expect from Docker, right? We introduced this pluggable databases with 12.1, and they actually provide a similar, on a concept level, a similar isolation and containerization of your data and your PLSQL code than you would have with Docker images for your application, right? Of course, you can deploy it on Exadata with advanced PMEM. This is the persistent memory support. We have that now as well. So we actually not only yes, you can store and run the same technology on your laptop or on a super high-end system called Exadata that actually already supports the new non-volatile memory that is out there, that just came out there a couple of years ago. The nice thing about for you is you don't have to worry about it. The database is smart enough to understand whether it's running on an Exadata, whether it has the non-volatile memory support or not. And it will address and leverage these technologies by itself and without, transparently to you, without you having to worry about. So there's no such thing as like, I have to recompile for this flag or redeploy or this or that or whatever. No, for you, for the application developer, everything stays the same. Doesn't matter whether this database runs on your laptop, an Exadata, or of course, cloud, could run on the cloud, right? We're going into the direction of autonomous database, which basically means make the database even smarter, right? So that perhaps it can even self-tune it, decide itself whether to create indexes and so forth. But also We have Docker images, and we allow you to also run, you know, the database for a long time in virtual machines. Now containers are very interesting as well. And so yes, you can deploy Oracle database also in a container, in an actual Docker container, right, or on Kubernetes. And we just introduced an operator for Kubernetes, et cetera, et cetera. So here again, like, we give you this flexibility of wherever you want to deploy, you can deploy the technology. And so you don't have to kind of have any trade-offs of like, I really want to use this database technology, but actually I cannot deploy it there, or I cannot use this underlying OS or this underlying technology with it that you would have with some other databases, perhaps. And again, really important is everything that's sort of below on this graphic from core down. You don't have to worry about. The database is smart enough to understand and leverage these technologies by itself as best as it can. So what does that mean? It's like, that all sounds great. Okay, so we covered, okay, we have different data type support, right? We have different data processing. We have access for the programming languages that are popular right now, many more, or support for programming languages, and many more. And we have a lot of deployment choices. So it's like, it means if you build it on Oracle database, you can pretty much run this wherever you like. So what does that actually mean? Well, let's take a step back, right, and discover a bit of like what has happened, or rediscover a bit and talk about what has happened in the last couple of years. It's actually, I believe, it's a really good time right now in the industry to be a developer, or to actually be a database developer. You know, like when I kind of came into the industry and just after the .com time in the early 2000s, the database landscape was pretty much like, yes, if you have a choice between Oracle, SQL Server, and MySQL, right? If you want to do anything serious, you go with Oracle done, right? It was really good for us, but there was actually not a lot of excitement going on in the developer system, about the developer ecosystem, about the data tier itself, right? It was like, okay, database done, let's focus on building the applications. And what we have seen in the last decade really is that we had a massive proliferation and search or appearance of different database or data management technologies, and it actually got the developer ecosystem really interested in that as well, right? It's like we had a merge of NoSQL database, we had big data come and perhaps go again. We have Kafka out there, right? This whole idea of stream processing or streaming, etc. And developers all of a sudden really excited again. And why is that happening? Well, okay, as we move the businesses into 24/7 workloads, I mean, we have done this since a long time, but every company essentially wants to be always online, always available, and sometimes even has to stay competitive. And we saw so many and still see so many different examples where entire companies' success is based on data, right? So it's like there's sometimes they refer to, it's like, look at Airbnb, it's the biggest hotel chain without owning a single hotel. Look at Uber, it's the biggest taxi corporation without owning a single taxi car. All these companies, essentially, their value is the data that they use and the service that they provide on top of the data, right? The nice thing for us here is, or the really exciting thing here is, it's like that we have this vast area in IT now where we compete on the level of data, which 20 years ago was like nobody did that. It's like it was new functionality, new features, etc. Everything took a long time, and so because everything got so fast paced, we wanted to compete on data. We got a lot of new choices on the data technologies and proliferation on there. And of course, now to stay competitive, or to actually, if you want to build something cutting edge, if you want to stay ahead of your competition, you really sort of have to be what we call data driven, right? It's like, it's no longer about build feature X over this other application, whatever. No, you kind of have to change your game and stay, or become data driven, and really leverage get the most out of the data that you have to get business value out of it, and essentially get success out of it. And when we look at the current ecosystem, it's like, because of that, we have seen also many different ways how to process data, right? How to derive that value. It's like machine learning is really popular right now, although the majority of machine learning algorithms are from the 70s. We just didn't have the means back then, the hardware, to store all the data in RAM and to run these algorithms on terabytes of data. I mean, in the 70s, nobody could even think of gigabytes of data, right? But now the technology is there, the hardware is there. Now we are on a completely different scale. So machine learning is really popular again, because now we also have so much data that it's no longer feasible to actually process it manually. Right, we need to be smarter. We need to stay ahead of the competition. Want to stay ahead of the competition, right? This ties directly into real-time analytics and IoT, right? It's like everything is just driven off machine-generated data, off all this online data, etc., etc. It's like there's no more the time for kind of ETL bot processes, etc. I mean, they still happen, but people want to get away of that. And of course, you have the whole aspect of understand your customers, your social graphs, etc. And that derives into, okay, we need to process different types of data, or that data is generated in different formats. And we don't actually want to kind of spend our time ETLing the data, but just leverage and get the value out of it. So these applications are built, with essentially also new paradigms, which got us into, the most definitely the microservices approach. It's the de facto standard of building applications, but there's also a lot of other paradigms that came along, and they all make a lot of sense for the development process and for the developers, right? Kind of be isolated, or perhaps just not dependent on other systems. When you look at microservices, right, the whole event stream, etc., makes a lot of sense for real time. When we looked at a data management and an overall architecture standpoint of that, we actually think that all these paradigms actually contradict or conflict almost 180 degrees with data management paradigms. So the data management, our CIOs and our data scientists, etc., they actually would love to have all the data in one place, right, in one format, etc. And the truth is, both worlds have to coexist, right? Because both worlds have different benefits for different users and for different use cases. But to build these out, it can massively fragment and overcomplicate your architecture. And this is when I said before, it's like, just if you wanted to introduce a new database engine for a new data type, you very quickly end up with different engines. Now multiply this by wanting to actually talk to these different systems, because a piece of customer information is over here, while a piece of the product catalog is over here, etc. Then you end up very quickly on an architecture diagram with something that you see here on the right-hand side, something that can become very complex very quickly. And a lot of the Silicon Valley IT companies or internet companies out there are very complex in their architectures, right? And there's a reason why they have thousands of developers to actually keep this all running, etc. So it's not a good or a bad necessarily, but it is a fact that the more you want to leverage different types of data, different technologies, different methodologies, this will or can overcomplicate your data architecture, essentially, that you have to build out. And that's something that's not visible to the individual developer, and that's not something that's easily visible to the IT department, if you like, in the beginning at all. It's usually when you kind of put all these things together where you get at a stage where it's like, wow, this has gotten massively complex, but now we're there. What are we doing now? And I think we strongly believe that the secret here is to essentially combine as many capabilities as possible into one data platform, right? And we like the analogy of a smartphone to say, yes, in the past we used to have our what's it called, a Discman, I don't even remember, right, for our music, right, our pager, our camera, our mobile phone when they came out. And today, all these capabilities of being able to listen to music, to take pictures, to have phone calls, to being texted, all of these capabilities themselves converged into a smartphone. Right now, nobody will think anymore about having many different things on themselves, or even want to. Certainly, I wouldn't want to. I already find my smartphone too big, honestly, but I wouldn't want to drag all of these devices around for these different capabilities. And we see a lot of synergy in that analogy. We're in the data world as well, right? It's like, just because, as I said before, you want to store JSON, do you really want to have a new database that you need to manage, understand, backup, secure, etc., etc.? Or can you address the need or the capability of storing and accessing JSON data with the same technology? That is where we're working hard on. And, you know, it's like Oracle database, as I said before, started this journey actually in the 90s with, you know, it started with object support, spatial support, XML, text, etc. Right, and we continue on this avenue. Latest, we have JSON support, we have property graph support in the database, just added recently. And we want to essentially give you, the developer, and any user of the Oracle database, the flexibility to leverage an Oracle database also for, you know, for non-relational data, for different use cases, right? So that we kind of allow you to leverage the same technology, but also your skills, your in-house skills, the code that you have written, the frameworks that you have, the tools that you have around it, etc., against the same technology without having to have any trade-offs in terms of bringing in a new technology and having to replicate that, or saying, okay, we can only do X with that technology, but nothing else. Now, here it's important to understand that, you know, it's like, of course, there will be scenarios where you will have many different database technologies or data management technologies alongside each other. I mean, it always has been the case. And that makes sense because they address different use cases, and maybe for some use cases, they're just fine and well enough. Another thing, what you see here on the slide on the left-hand side, is not that we say, put all your data into one database, or, you know, put everything into one Oracle database. But what we're saying is, like, we have a lot of these capabilities, you know, of different data types and these different infrastructure resilience aspects built into Oracle database as well. So that if you wanted to use an Oracle database as a pure document store today that is sharded, you can. It's like you don't have to use any other functionalities if you don't want to. So it's fine, right? And you can spin up another Oracle database somewhere alongside and use it as a traditional clustered relational database. Or a graph store and so forth. All of these things are built in, these capabilities are built in for the in the database, and you can leverage them. The one nice thing that you get of it is that you know, any data that you put in an Oracle database, you secure in the same means. You can access via SQL and make sure that every data is accessible via SQL as well, which means now you can analyze it together. You know, you can join against different data types and query them together, etc., etc. So you have these powers that you do now get when you combine the data that you would not have otherwise. On the same side, if you look into the right-hand side, you know, here's one example of what this could look like for the on a deployment scale, but it's one example, right? So it's like microservices are the de facto architecture. They are de facto spun up in containers these days, although the architectures doesn't really dictate that things have to be spun up in containers. Everybody likes to spin up the applications in containers these days for obvious reasons, or for apparent reasons when you look at the technology. And that's okay. And, you know, like, you could spin up an Oracle database if you would like to, each time for each of those microservices, or you can leverage, as we said, the built-in containerization technology that we have with pluggable databases to essentially make the management aspect easier. It's like, it doesn't per se mean anything to the developer whether they connect to a pluggable database or an Oracle instance. It remains exactly the same for them for every intents and purposes that they connect to an Oracle database, have a schema, and do whatever they want to do in there. And as said, they can use this as a document store if they want. They can use it as a regular relational database, as a graph store, or they could combine it if they wanted. They could store relational data alongside with JSON data, etc. All of that is possible. And with these possibilities, there's a lot of options now that you get when you think about how you want to build applications, how you want to deploy them, right? Said before, it's like we also introduced sharding into the Oracle database. So if you wanted to have a sharded environment, you could, like you see here. If you want to run the clustered and rect, it's fine. Single instance, it's all fine. But important, what we think is important, is giving you the flexibility to essentially, when you have a new business need or a new requirement emerge, that you can fulfill that requirement in Oracle database as well. You don't have to now take your data to somewhere else, spin it up and build it around there. Now, it was a little bit more than 25 minutes, more like 35 minutes. I apologize for that, but that's on a high level, the kind of what the landscape looks like, what has happened in the developer ecosystem on that. That point, a quick check-in, Patrick. Did we have any questions so far?
Well, the only question was free is no additional charge, right? And I already answered no additional charge on top of your license. And of course, we have the XE version and the free cloud.
Perfect, great. Thank you very much. So now let's drill into some of the actually the features that we've introduced, the good stuff that you can leverage today, or hopefully are already leveraging today to build applications. Let's start with Apex. If you don't know Apex yet, Apex is our low-code development platform. I mentioned it before. It's basically built on top of PLSQL or leveraging the PLSQL engine, and it allows you to Apex allows you to do many things. Actually, so it's a web-based low-code development platform. It allows you to build web-based applications without having to write tons and tons of JavaScript code, etc. It's very declarative that you can put together, but it also allows you to create REST interfaces if you would like to do so. It allows you to, even the simplest workload would be, or the simplest use case would be, just kind of build a Google Sheet kind of thing inside the Oracle database. So we actually, this is sort of how what Apex's inception point was. We were like, we no longer want to send spreadsheets around emails. It would be really, really nice if we could just, have one spreadsheet that's stored somewhere centrally and people can actually modify it together at the same time. This was back in 2004, way before Google Sheets was even a thing. It's inception point of Apex. But the really nice thing about Apex is you actually see a lot of applications out there when you pay a bit closer attention are built around Apex. So if you use Ask Tom today, it's built on Apex. If you use the Dev Gym today, it's built on Apex. Live SQL built on Apex, and so many more applications are all built on Apex. And it just allows you to write applications much faster without having to write tons and tons and tons of code. And the really good thing is it's also fully free. You can install Apex on top of Oracle Database. It's included with Oracle Database. It's there in the free cloud on our cloud services. And you can run it off XE or Enterprise Edition, etc. It's free of charge. It's essentially a component of the Oracle Database that you can leverage. And I highly encourage everybody to look into Apex. It's gotten really successful. We have some really interesting use cases out there, what our customers are doing also with real-time analytics based on this web-based interface that they all built in Apex. Really, really powerful. If you want to know which other applications out there, just there's a really nice website built with apex.com, which itself is built in Apex, that lists you a lot of the technologies or websites that you see today that are all built with Apex. CSD Pipelines. This is actually a really important area as well when we look into the overall ecosystem, how to tie in Oracle database into modern CSD workflows or pipelines altogether, into rolling out changes. We do have REST APIs for PDB management. So lifecycle management APIs, this actually allows you a REST interface just to spin up a new plugin database and destroy it. You can leverage this with Jenkins or any other CI/CD pipeline tool to essentially create new environments and destroy them as you run through your CI/CD workflows. We have, as mentioned before, advanced liquid-based integration in SQL CL. Liquid-based integration in SQL CL. So if you don't know liquid-based yet, liquid-based is a tool that allows you to essentially record and roll out schema changes. In order for CI/CD to roll out schema changes alongside with application changes, we recommend liquid-based as the go-to tool. It's an open source tool out there. And SQL CL has integration to allow you to create what they call these change sets, etc., deal with all these database objects that we have in Oracle database. And online schema upgrades are really important as well to actually roll out these changes, especially in production environments, without causing any downtime. There you will see that over from 11G onwards, like a lot of the DDL commands have actually just become like always online commands. So basically you don't require you to turn off your workload or take any downtime, whether it's like to move your table over, to create an index, etc., etc. These are kind of all the nice little goodies that we would bring it back again. Those things matter when your system gets big, is production. You don't want to take out time anymore and so forth. And of course also addition-based redefinition is a really important aspect to that allows you to addition your schema changes as well as your PLSQL. Mentioned before already numerous times, the database has a document store, so we have full JSON and XML support, native support for these things. Fully aware, the SQL engine is fully aware of these, so you can either use document store APIs, like for JSON, for example, we have Soda APIs out there that you can leverage with, whether it's via REST or Java or JavaScript, Python, etc. But you can also write SQL queries against that. You can leverage SQL as well. So it's kind of like you get the best of both worlds. You can store it natively, retrieve it, and this is a Word document store. Or you can actually store JSON data, query it, create views on top of it, even insert JSON data as if it were relational data. It doesn't matter, whatever is your use case, whatever is the right tool for the right job. When we look at event-based architectures, we're doing a lot of work currently with integrating it with things like Kafka, and providing better queuing support or better streaming support in the Oracle database. So one thing that you do see here, this is essentially an AQ slide. So advanced queuing is a technology we have since a long time in the Oracle database that provides you with queuing support in a database. And I just mentioned it specifically here because we used to call it streams advanced queuing at some point. And we actually deprecated streams with 12.1, and a lot of people thought that we also deprecated advanced queues. That's absolutely not the case. Advanced queues are there. We're actually adding much more support for them for a higher throughput, for faster queuing, dequeuing, processing, etc. And as said, with Kafka integration and many, many, many more things. The nice things that we have on top of that is that, again, here we provide you full asset transaction guarantees and other things that help you, that you don't have to deal with and with reconciling your data afterwards. IoT workloads, we have actually really cool new functionality, and I believe it came in 12.2 or 18c, not quite sure, that allows you to ingest IoT kind of data really, really fast into a new memory area. We call it Mem Optimized. Is a property that you set on the table. And essentially what it allows you to is to insert data really quickly without having to write it to disk. It goes all into a memory area and is periodically synced on disk. And it's like especially geared towards things like any kind of sensor data, where you get a lot of data really quick, a lot of tiny little bits and pieces, and latency is really, really important. And you cannot just go like, oh, you don't want to necessarily kind of like wait for your commits to happen every time, etc., etc. So this is really cool. It's like we did a test, it's like 25 million inserts per second on a 2-socket server, because you just load all this data into memory. RealTime Analytics, this is kind of a memory option, something that we've introduced in 12.102. Allowing your database to represent your data also in a columnar format and an in-memory columnar format. This really drives real-time analytics. This really drives, those queries that run through terabytes of data to run your aggregations, etc., etc. Makes your analytics 100 times more faster. A really nice thing here is, again, it's like no changes needed to an application, nothing. It's like you just turn the feature on a table. If the database is smart enough to say, okay, I'm gonna take this data, I also represent it into columnar, and still keep all the transaction guarantees that you have, all the security guarantees that you have, etc., etc. It all just sits in an Oracle database, and your optimizer is smart enough to know which one to access and how. Built-in machine learning in the database, something that's actually around since a long time, used to be originally called data mining. I mentioned before the data mining, the machine learning algorithms are actually is kind of old. They're around since a long, long time, but we also said that being around for a long, long time is not a bad thing. You have most of the modern machine learning algorithms that are hyped out there today, if not all, right there in an Oracle database as well. So if you wanted to run machine learning algorithms on the data that sits in an Oracle database today, or will soon, you can do so. Additionally, we give you a Python and R support on top of that, right, built into the database. And we have also new functionality that came out, I want to say, that's coming soon, actually, AutoML, which is actually even allows you to kind of figure out which machine learning algorithms to leverage against your data that you have. Really important, this used to be an option. It's no longer. So it was part of the advanced analytics option. It's actually now free in all database editions since about 2 years. The advanced analytics option no longer exists. Graph analytics, I mentioned this before as well. You can store graphs as well. You can run property graph query language, PGQL, as well if you wanted to. It's like for a graph developer, data scientist, this might be more natural than SQL, or you can of course run SQL against it as well. Used to be part of the spatial and graph option. Same thing here. It's actually free in all database editions now since 2 years. Spatial and graph option no longer exists. So you can leverage this today with your Oracle database right there. Blockchain data. This is actually something, sorry, I need to take that sticker off there. With 21C, which came out just a couple of months ago, we introduced a new blockchain data table type in the Oracle database. So we're allowing you to have these tamper-proof ledger tables also inside the database if you have these use cases in financial industries. They love this kind of stuff, basically an insert-only a table where nobody can change or drop the data, and you cryptographically chain the changes to the inserts together, just like a blockchain, what you have in blockchain out there. You can do the same thing in Oracle database if you have such use cases. Really, really powerful. Spatial, just mentioned with spatial and graph option. So same thing here, spatial and graph option no longer exists. So all our spatial capabilities that we have in the Oracle database are there for you, free to use. So really nice things, that you have with spatial allows you to do something like this. You can essentially say, hey, I want to find a certain store or something with the distance of, in this case, for example, 5 kilometers, right? And where the name is, and this got not bad Bob's. Like, give me all the restaurants that we have here. Simple SQL query that does actually spatial analysis on geometrical data, on longitude, latitude, to tell you, yes, within that point of the world, like there's these restaurants that I have in the database that are within those 5 kilometers. Really, really powerful capabilities that we have. Multilingual engine coming first introduced in 21C as well, and much more to come there. The capabilities to essentially run multiple programming languages as stored procedures in the database. So we're leveraging GraalVM here. GraalVM is a super exciting technology that Oracle Labs has built that allows you to run and compile many different languages down to Java bytecode and then execute it into one VM. We're leveraging right now today in 21C to essentially run JavaScript stored procedures that Apex, for example, uses. So we allow now users to write, Apex developers to write JavaScript snippets to execute, and these execute inside the multilingual engines. The long-term vision for multilingual engine is to essentially allow developers to write any kind of stored procedure or user-defined function in their language of choice and put it in the database. Why do you have to use a different programming language that you're not used to? If you're a Java guy, you want to write Java, that's fine. And we have OJVM as well today in Oracle database to actually facilitate that. But we see this every couple of years coming along where people say, hey, now Python is really popular. My data scientists want to use Python. Can we use Python for this? Or like R used to be really popular a while ago. And, point being is like, yes, same as with the data types. It's like, we want you to essentially write logic in the programming language of your choice, or perhaps even more important, reuse code that you already have in language X and run it in the database side as well. And the next big thing that we have on the horizon is persistent memory and RDBMA on top of that. So this is, as I mentioned it before, PMEM, right? Non-volatile memory. This is a whole new interesting area happening for databases, because databases have been built around caching data in memory so that they don't hit disk. But with non-volatile memory now becoming your disk essentially at the speed of memory, a lot of things change. And here as well, actually, we already added support in database 19C for this. We already worked with Intel on this and started adding the instructions, etc., that we need when non-volatile memory is coming. Now it has emerged, and there's much more to come on the horizon. So just watch out for that. And something really exciting that we're doing is, for example, Exadata or other technologies to use this remote direct memory access, RDMA, to connect from a server directly into the persistent memory on another server without having to go to many of the networking layers end. This will like reduce latency by multifold. So that's sort of just on the side, but not so much developer related, but showing you the innovations that are happening. Of course, cloud, we have a lot of different cloud services out there for you to use and build your application, as well as Oracle database cloud services on there to leverage as well, including autonomous database. So always worthwhile to check that out. And there we do have an always free tier as well. And, bringing this to a close here with 50 minutes in, the truth is of an Oracle database, it should be your, really should be preferring reliability and functionality over popularity, right? As we said in the very beginning, it's like a lot of what we see as newcomers, they're not that new anymore either these days, but a lot of the NoSQL databases and other people come out, it's like, yeah, everything is just legacy, etc., or Oracle is legacy. Well, actually, Oracle still runs today and for a long time, much longer than these databases exist, the world's most critical 24/7 business workloads, right? And securely, it's like you look into any of these major companies with like sophisticated use cases, Oracle is the go-to choice. The no innovation, not true one bit. It's like we have functionality built into Oracle even before it comes out, before they even see it. Like this PMem was one of these examples, no volatile memory at the very end, and so many others with multilingual engine and coming. Expensive. Well, it's a question of the right tool for the right job. It's like we've just shown we have free versions of the Oracle database to leverage. We have many different deployment choices and many different also choices of how to license it, how to use it. And one thing that kind of gets forgotten is like, well, if you don't have to run 15 different technologies or 15 different databases that you license all separately, it's like, is it actually still more expensive or not, right? It's like, what does expensive mean in that context? Not flexible, not true one bit, numerous features and data type supports and the complexity, it's actually by far less complicated if you can execute spatial or machine learning algorithms via SQL, alongside your relational JSON data and then to build this all out into a distributed fragmented data tier environment. And with that, I would like to thank you very much for your attention. And if there